Ready.
Okay. Many thanks to those of you that did this on time. I think as of today, I still got the notification. I thought I locked it like after 6 p.m. yesterday. You shouldn't be able to. Maybe I did not. So, lucky you, whoever that is. I got a notification like somebody submitted investigation. I'm like, wait, what? But anyways. So in this investigation, the idea is to see the behavior of a quadratic graph in different forms, because that is the basis of what we are going to do today. By the end of today, all things being equal, I want us to have completed sketching graph of quadratic. So tomorrow I might give like maybe practice to the SL while I focus on the HL throughout the 2 lessons. But anyway, I have a worksheet here just in case. The first thing that you had to do was to, see what happens to this form, and you substituted, and I asked to find the X-intercept. Everybody got that right from what I've seen so far. The X-intercept will be these 2 values, okay? So in this case, it's going to be 1 and 3, not -1, -3. It's like the reverse of what you see in the bracket. So everybody got that right. Then the next thing I asked is, what is the significance of A? So what I want you to notice is that the bigger the value of A, the narrower the graph becomes. And if A is positive, you have a minimum curve in this form. Maybe I demonstrate. Wait, what? Okay, sorry. Disconnect, reconnect. Yay! Uh-oh.
No.
Uh-oh. Shame on you. Those of you making fun of me. Shame on you. I'm back. Alright, should be okay now. Alright, so let's see what happens if we have 2 bracket x minus 1 bracket x minus 3 compared to if you change that to 12. You see it becomes narrower, or maybe 5, okay, or better still the same x minus 1 x minus 3. Let's reduce this to 0.5. Okay, come wider. Oh, maybe these are just positive. Let's change it to -5. Let's have minus 0.5, or maybe -1/3, or maybe -1/10. Can you see that? So it's not a function of positive or negative. That is why absolute value is necessary. Those of you that replied to your comments, if you have checked, I've replied some comments. I haven't replied some of them. I said absolute value of A, not A. Absolute value of A is very important. Okay, so whether A is positive or negative, as long as that value looks smaller, you're going to get something that looks wider than when the value looks bigger. Understand? And when A is positive, you're going to have something of this form. When A is negative, you're going to have something of this form. Okay? Okay? So please take note. We're going to talk about that extensively. This is A less than 0. This is when A greater than 0. We're going to talk about that extensively on that turning point. So that's the first part that I needed us to get this has been printed. And then let's talk about in the investigation. Is there a way we could capture both, Joey? It's going to be smaller?
Yeah, I'm afraid that's not going to be clear. It's okay, I can just...
Sometimes I could just, I want to scribble something and I don't want us to miss that.
It's okay, I'll try to not miss that.
Okay, thanks. Now, for the second part, you were to check the significance of P and Q. Let me see. So I asked you to do all that, then I said find the X-intercept. The X-intercept remains what you have done. Significance is that P and Q are the X-intercept. I think that was quite straightforward. It's just like an extension of question 1. Am I making sense, please?
Yes.
Then in the third type of problem that I've given you, you see, everything is still about this factorized form. Okay? But if x minus p is the same as x minus q, then you are going to have all squared. What happened to your quadratic at that point? So find the x-intercept. X-intercept remains what you have here. Okay? Then I said, what is the significance of p? That is your x-intercept, isn't it? Then I ask you to complete the statement here. If a quadratic has this form, then it crosses or it intercepts. There's a difference between intercept and touches. When it intercepts, it crosses and it goes to the other side. Touch could just be touch and come back, not crossing. They're two different things. So what I needed you to tell me was, in this case, it only touches. It doesn't cross. Show you what I mean on decimals now. Let's say we have two brackets, x minus 1, then all squared. Wait. You see the difference? Let's remove a lot of this nonsense. While the blue graph crosses, the red one touches. Okay? So there's a difference. It touches, it doesn't cross. Cross means you know what's on the other side. In this case of the red, it doesn't know what is on the other side. It touches the wall and come back. Okay? So that's the minor difference I needed you to observe here. I think some people were able to, some were not able to. If you are not able to, I will reply you as a comment and give you what you are supposed to say. Kindly take note of those things. But of course, if you notice, those are graded so far. Hardly did I give anybody a 6 point. I just gave 7.7. Because the idea is you already know what to observe. Most of us just have minor issue communicating those ideas. So that's why it's not a big deal really. But henceforth is a big deal. Now, for the second part, if your quadratic is already in this form, because these are the issues, these are the types we are focusing on today. If your quadratic is already on this form, what do you notice? From your observation, you will have noticed the vertex is this x and this number standing alone. Let's take a few examples. So you notice this is 1, 3. 1 from the bracket in here, 3 here. From your IGCSE knowledge, you should remember this concept of completing the square and finding the turning point using completing the square method. Do you remember that?
Yes.
Well, we are not assuming, everybody knows, so you don't need to panic. When I get to that point, the next point after this is completing the square. So we'll look at that. By the end of this week, everything on quadratic and maybe graphing should be done. I don't think maybe we can finish everything today, but I'll try. Because I don't want to leave on this stone unturned and pretend we know and just rush through things. It's going to affect you later. Okay? Anyways, so if I pick another one, maybe we are just lucky in this case. Let's pick another one. Let's say 1. And let's make this plus 5. And let's make this maybe minus 4. Let's look at the turning point. The vertex is minus 5, 4. So that's like opposite of the sign in this bracket and the exact number you are seeing here. Those of you that remember from IGCSE, this should not be a string to you. You should know what it stands for. But in case you don't know, or you are not familiar with it, or you haven't done completing the square, this is an opportunity for you to know as well. It's no big deal. So clearly, in this case, the vertex will be 3, 2 in each of them. And some of you were writing x is equal to 3, y is equal to 2. No. Look at what I wrote here. Coordinate of the vertex. The vertex is a point. I just need your result to be in form of ordered pair. 3, 2. Someone was writing so many stories. So when x is equal to 2, y is equal to 3, please, you need to stop writing story. It's not about the quantity of what you have written, but about the quality of what you have written. Alright, understand? So somebody might write a convincing line, a convincing mathematical maybe solution in 2 lines. And you have written 15 lines and you still don't get what that person has gotten because you are bringing in the relevant stuff. You are not focused. And I believe that is an important part even for your extended essay. It has to be focused. on what you are talking about, not diverting here and there, just to make sure you have 3,000 words. Understand? So please, let's focus on that. So similarly here, so it doesn't matter which of the functions, each of them will have the same vertex. You might be wondering, but they are different functions. Yes, they are. Some of them will be maximum, some of them will be minimum, some of them will be narrower, some of them will be wider. That's the implication of A. It doesn't change the fact that the vertices will be the same. Okay? And I'm sure a lot of you observed that already. I'm just reviewing this so that if anyone did not observe, or maybe out of 100% of what I said, there is a 1% that is new to you, then you can add to what you have known. Okay? So quickly, what is significant of A? It only tells you the shape. Okay? Is it going to be concave up or concave down? Concave up is this one, the minimum. Okay? Concave down, the maximum. Okay? Concave down, that is where it faces when it turns. Alright? Concave up, concave down. That's the significance of A. In fact, not only when we have it in this form, thank you, Joey. Not only when we have it in this form, even if you have your quadratic in this form, because that is what is responsible for this. Okay? If your A is positive, you have a quadratic, no, this one, sorry. If your A is positive, you have a minimum type quadratic. You'll be discussing the minimum point or the minimum value. And if your A is negative, you'll be talking about the maximum point or maximum value. Understand? Both of them are called turning points. I think we talked about that the last time. Thank you. So that's significant of A. So on this one, I said on the same axis, I think it's similar. The significance of H and K. In this case, H and K tells you the coordinate of the vertices. Alright? So X, that would be H comma K. H. I think a lot of you wrote that. And that is what I asked you to complete here. Okay, if a quadratic has this form, its vertex has coordinates H comma K in the bracket. That's all I ask you to do. Understand? So well done. I think the class really did well. I've seen a lot of feedback. Oh yeah, impressive. The only minor things like absolute value of A instead of A, those are the minor things that most people missed. And maybe how to write a comment, or maybe how to be focused. It's okay, we are still all learning. So over time, that is why this feedback is very important. That is why you need to get your work done on time so that we can all have this feedback and learn from mistakes. Okay? But if few people submitted, I'm not able to share feedback, I just mark, I give you different times, you're not able to get maximum correction. Okay? You need optimal stuff. Anyway, now, that's the summary of the investigation. Now let's now summarize it in a table and how it can help us to sketch a graph. Okay? So this is in three forms. So please write. If the quadratic is, so it's not just the summary from the investigation. The investigation, the introduction we did before the investigation, we are not going to put it into use for sketching. Okay? If the quadratic is of the form y equals a into bracket x minus p, x minus q, your graph will either be in this form or your graph will be in this form. Can somebody tell me, when do we have this one?
When the A is positive.
A is positive and this is negative. Alright. You see, P and Q are intercepts, isn't it? So this might be your P, this might be your Q. So that will help you to get the axis of symmetry. Maybe I use a broken line. So this is not like the y-axis, please. It's not the y-axis. So maybe I use a broken line for the axis of symmetry. So you don't think this is my xy axis. Does anybody remember what axis of symmetry means?
It's the part where it reflects over.
Not quite. I get what you mean. Is that line that divides the curve into two equal parts? Okay? So this is your axis of symmetry. So let's say we have for the second case also, like that. So this is your P, and this is your Q. So this is your P, and this is your Q. Because the axis of symmetry divides into two equal parts, the distance between this line divides into two equal parts. The distance from here and here are the same. Everybody please pay attention. Because this axis of symmetry divides the parabola into two equal parts, then you have the same gap. Am I making sense? So that's like the midpoint of P and Q. And how do we get midpoint? How do we get midpoint of two numbers?
Take the 2 divided by 2.
You plus and divide by 2. You add them and divide by 2. So if the question is asking you for the equation of the axis of symmetry, it means with your X-intercept, you can actually get the equation of the axis of symmetry. That's what we want to bring out here. Okay, one of the facts. Okay, please write. If this happens, 1, P and Q are X-intercepts. 2, this is small letter P, please. The equation of the axis of symmetry. You see, axis of symmetry is a line. That's why I said the equation of the axis of symmetry. So it's like saying the equation of the line. Am I making sense? Yeah. The equation of the axis of symmetry is it going to be in X form or Y form? This line.
Why?
Oh,
X.
X form. So it's going to be X is equal to that. Okay? Are you okay, sir? That's that. Okay. Now, remember, the X coordinate at this point is also the X, whatever you get here, right? So once we get our X coordinate, we can use that to find the Y coordinate. Am I making sense? And you can get the coordinates. Understand? I can get the X, the coordinates of the vertex. Again, if this is 1 and this is say 7, then the midpoint is what? 4. Right? That's 4. So this line is actually the line X is equal to 4. So X is equal to 4 is the line that divides the parabola into two equal parts. That's what we are saying. What else can we do with this information is that, oh, at this turning point, X is equal to 4. Because remember, it passes through the turning point. Okay? The final clue is that, oh, when X is equal to 4 at this point, what is the corresponding Y? In case you need the coordinate of the vertex. Your X is here, your Y is just when X is equal to 4. Understand? So, because these are important features when you are sketching a quadratic graph. You want to talk about the intercept, you want to talk about the, what's it called? The vertex and the axis of symmetry. Okay? So the last point I'm going to write here. At the vertex, I'm trying to paraphrase what you have in the book and put enough information for you. At the vertex, X is equal to P plus Q divided by 2. This can be used to determine the coordinates of points at the vertex. The most trivial one, which we never mention, for all quadratic anyway, is that if A is greater than 0, if A is greater than 0, you have a minimum, isn't it? So it's going to be concave upward. Understand? The graph is concave upward, and if A is less than 0, the graph is concave downward. So this clue of concave upward or downward will not be repeated in the other forms. I should have actually written it at the beginning, but it's fine because it's a general observation, regardless of the form that we have. So the second one, if A is in the form of perfect square. Mr. Alex, everything good? Yes. Okay. If the quadratic is of the form y equals a into brackets x minus b squared. Again, what is the difference between this form and this form? The curve versus the x-axis. What can you say about these two forms?
This intersects, the other one only touches.
This intersect, this touches. That's the major difference. Okay? That's the major difference. So it's going to look like this. So x, again, maybe I put here x. We are not focusing on y-axis, we don't care. Understand? For now, we don't need it. So all this blue line that I'm drawing is the x-axis, please. Okay? So in this case, it's going to either touch like this or like that, depending on the value of what?
A.
A, thank you. Depending on value of A. A determines which of the direction, yeah. Now, from your investigation, we know that this is P. It touches at P. P is that X-intercept. So, X-intercept is P. What about the equation of the axis of symmetry, anyone?
It's the intercept.
X equals to P. It's going to pass through the same X is equal to P, isn't it? So let's draw the axis of symmetry. So if this point is P, then this line is X is equal to P. Basically, that's what we are talking about. Okay, and with X is equal to P, you can substitute to get the corresponding Y. Okay, so again, I will be silenced about how to get Y, the longer part. Okay, so let's write number 1. P is the X-intercept. That is where it touches, this time, not crosses. Touches X-axis. It doesn't cross this time. 2. The equation of the axis of symmetry is X is equal to P. At the vertex, X is equal to P. Then we can use that to get corresponding Y. In fact, it's trivial. When X is equal to P, what happens to Y? Y is 0. Remember, it touches X-axis, which is Y is equal to 0. So we can actually write about X equal to P. Okay? So that the coordinates of vertex is p comma 0. Because touching the x-axis means y is equal to 0. Am I making sense, please?
Yes.
So the last form from our investigation, this is like the first part of the investigation. Remember, the first part is when you have two linear factors and when you have repeated factors, right? So when you now have the one in the completing the square format, the last part, if the quadratic is of the form y equals a x plus b squared plus c, something like that. It's of this form. Let's have a sketch again. In this case, we are not focusing so much on the intercept. Our focus is on the vertex and the axis of symmetry. Okay? So, you must have noticed that your vertex will have b comma c. Is it minus b? Are you with me?
Yes.
Minus b comma c. If the vertex has minus b comma c, then you can talk about easily the equation of the axis of symmetry. Yes? What would be the equation of the axis of symmetry? X equals negative b. It's as simple as that. Okay. So let's follow the same format and try to indicate. So one point is that the vertex is negative BC, and that also implies that the equation of the axis of symmetry is x equals negative. Okay. So these are the important things to take note of. Now let's use this to do some interesting sketching. I'll put that on board. Let's look at this. Hopefully it's not too tiny. Let's see if we can match ourselves. It's too small, right? Can you see from the back? Huh? Okay. Can you see from the back? Right? Right. Okay, so let's see. All these functions, these are the graphs. Please tell me if you can see. Can everybody see? Yes. Okay, all these functions, these are the graphs. Let's try to match. Let's start from function A. Which of the graphs do you think represent function A? Let's look at it together. That's my new phone. D. Somebody said D. Okay, let's see.
No, sorry, my bad. No, not D.
Okay, it's withdrawing a statement. Please think before you say something. And once you have said one, can you chill for the next person to also have a chance? All right? So who wants to go first? Let's you first. B. So this one for B.
Yes.
Okay, let's see together. Here is a minimum one. Concave upward. So this is concave upward. Maybe it's right. The intercept are 1 and 4. Yes, it's right. The y-intercept means when x is equal to 0, right? All you have to do is substitute.
Oh, I'm wrong.
When x is equal to 0, shush please.
Sorry.
When x is equal to 0, you have minus 1, minus 4. Minus 1 times minus 4 is what? Plus 4. Times 2, 8.
Which is
This is not
C.
8, so this is wrong. So what should it be? C. You see, they look alike. It's a trick. A trap. Alright? Don't fall into the trap. Okay, so let's pick another one. So everybody get that, right? Let's pick another one. Who wants to try B?